In this video, we'll learn how to use Excel to plot a scatter plot, find the correlation coefficient, and also doing some linear regression analysis. The first topic is how do we graph the scatter plot by Excel. For example, construct a scatter plot for the following pairs of xy. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 value for x and 9 value for y. So the first step is we need to enter everything to Excel. That is very easy, right? You can enter these two columns in any cells. I pick a random place and I put x and y, I label it, and then I just enter all the value in. And after you have all the data in, we are going to highlight both columns. Go to Insert and then click on the scatter plot here and pick the first option. And it will show you the scatter plot. Okay? Now let's do that. We will highlight everything, two columns, go to Insert, and then this is the scatter plot, the first option here, and here you go. This is your scatter plot. And then inside the scatter plot, you can always click on the quick layout charts, and you can like choose a different layout that you want here, or maybe this one, so that you can enter the asset titles, right? Or even this one, it's had the asset title y, x, and then it has the grid for the graph. Maybe this one here, it looks nice. And you can also zoom in, right? You can also zoom in. The reason here we need to zoom in because we want to see clearly if the dots are related to each other linearly or not, or any kinds of relationship that we can see from the dots. Looking at the graph like this, they are all together around this spot, so it's difficult to see, right? So you can like click on any number on the x-axis and then right click, and you can click on format axis, right? And then from here I see that most of the value for the x-axis, they start around 60 and above. So the mean value, I don't want to set from 0, but maybe I'll put 55. Enter, right? You see now it's zoom in, it starts from 55. And then similarly for the y value, we don't have anything down here until 40, around 60 something and above. So let's just click on a random number and then right click format axis. And then the mean value, I want to make the adjustment, maybe start from 40. And now you can zoom in, or you can even change it to 50 because we still have a lot of empty spots down here. So enter. So now it's easy to see if we zoom in around the dot area so that we can see if they have any special pattern or not. And yeah, that is how we zoom in the scatter plot. Okay, and don't forget that you can always rename the title. Maybe this is X and this is Y, right? You can type anything that you want, and you can also change the quick layout from here. Okay. Next topic is the correlation coefficient. We use the function correl, C-O-R-R-E-L, correl, array 1, array 2 are the two inputs to calculate the correlation coefficient of the two data sets. Array 1, the first input is the list of all the x values, and array 2 is the list of all the y value. Okay, so for example, I want to find the correlation coefficient R for this set of data. So what I do, I want to find the R value, right? The correlation coefficient. So I press equal, correl, C-O-R-R-E-L, and then open parenthesis. Array 1 is my X value, and then put comma, and then array 2 is my Y value, and then close everything and hit enter. And it will give me the value of the correlations of the two set of data. That is one way. Or you can always click on the formula, right? You can always click on the formula, insert the function, and then choose the statistical, and you can scroll down and look for the correl here. Click OK. Array 1, I just drag everything from the X. Array 2, I just drag everything from the Y, and then it also shows you the answer right here, minus 0.146, or you can click OK. It will give you the same thing. Okay, next topic is the linear regression. Regression analysis is used to describe exact linear association between X and Y. It helps us to predict the value of Y from the value of X. And recall that the slope-intercept form of linear equation is Y equal mx plus b. This is the standard slope-intercept form. M is the slope and b is the y-intercept. To get this linear equation, we first plot a scatter plot and then display the equation of the line through the dot. Okay, through the dot. All right. So for example, I have this set of data x and y. So let's try to find a regression equation of this following data. So let me type in a new set here. I have x and y. I have 2, and then 4, 5, 8, and 9. And then for my y, I have 3, 2, 6, 5, and 8. To find the linear equations, the first steps I need to do is I plot them. So I highlight everything. I highlight everything again. Go to Insert, and then go to the charts here. And this is the scatter plot, right? And then I can click on the dot, right? Left click on any of them. And then you can click right click, and you choose the option Add the trend line. Now our analysis is about linear, right? So we choose linear, not the other option. Linear, and now you also want the equation of that linear. So you check this box. It displays equation on the chart. And we can also display the R square. The R square is the coefficient of determination. This is just the square value of the correlation coefficient. To find the correlation coefficient, we can always take the square root of this value to get it back to R. So now our equation is 0.6506x. This is the slope, plus 1.1566. This is the y-intercept. Right here. So the slope is 0.6506 and the y-intercept is 1.15. That is how we get the equation for any set of data using Excel.